Let's begin. Today's September 18th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 6, 11, 17, 21, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our first digit, the triangle digit, and compares the value to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should triangle be greater than 3? Criteria card B looks at our middle digit, the square digit, and the Turing machine will let us know if it's an even digit or an odd digit. Criteria card C looks at our first 2 digits, triangle, square, and compares them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card D looks at our 3-digit solution and will let us know how many of those digits are even. Are there no evens? Is there a single even? Perhaps 2, maybe even all 3 are even. Criteria card E again looks at our 3-digit solution, except this time it tells us a little bit about its structure, so to speak. One scenario is that there could be a single pair in the code, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again looks at our 3-digit solution, looking at triangle to square to circle, and will let us know a little bit about the ordering of those digits. Are they in an ascending order, meaning that they're increasing, as in the example 135, or are they descending, as in the example, or decreasing, as in the example 421, or could they have no order? So let's look at this example 231. Notice that it goes from 2 to 3, so it increases, and then it goes from 3 to 1, and then decreases. So it's that shift. That's one way to describe a 3-digit code to have no order. Other examples that we've seen in other puzzles is when you have consecutive digits, digits that are right next to each other, that are equal. Say, for example, 115. So if you have consecutive digits, there is no change between the 2 ones, the 2 consecutive equal digits. So having no change is another way to describe a 3-digit code to have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I want to test is criteria card B. Okay, so since criteria card B has to do with the square middle digit, I did choose an odd 1. The Turing machine does not approve of that, so it's letting me know that in fact square should be an even digit. So let's go ahead and type that up in our notes in section B. And that again is that square is an even digit. And since it is even, let's go ahead and cross out all of the odds. So crossing out 1, 3, and 5. So the next thing I want to test is criteria card E. I want to know if there's a pair or no pair. Okay, so the Turing machine does approve of my proposal. Notice that in my proposal of 314, they are all distinct. So that is that falls under the category of no pairs. So let's go ahead and type that up in our notes for section E. And we'll say that the solution has no pairs. So at this point, I'm not sure if we can definitively say that It could be a single digit repeated 3 times. All we know is if it is, it's got to be an even. So that means that we'd have all evens. Let's see. Can we say anything about that? If we have all evens. Well, I think if we had all evens, it may fall into the category that it would force this to be of no order. And I don't think we can say that. But I don't think we have 3 evens. Obviously, we do have 1 even. So it's either between 1 or 2. But they are all distinct. So let's see. Is it worth testing criteria card D, the number of evens? Yeah, let's go ahead and test. Let's go ahead and test criteria card D. Let's see where that leads us. Okay, so it does approve of my single even. I only have 1 even in my proposal, and the Turing Machine agrees with the structure of it, having just 1 even. So let's go ahead and type that up in our note for section D. And that's that the solution has a single even digit. Okay, and of course, since square is already defined as even, that means that both triangle and circle are odd. So we can go ahead and cross out the 2 evens in both triangle and circle. So we're looking at a solution that's odd, even, odd. Okay. Well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card A, comparing triangle to the number 3. Obviously, we now know it is odd. We also did not test comparing the first 2 digits of triangle and square. Again, now we know it's odd versus even. And of course, we did not test the ordering of the digits. So let's see. I believe let's think about criteria cards C and F for a second. So if I knew that the ordering of our 3-digit solution were ascending, meaning that it's increasing, I would know that triangle would be less than square, making this card irrelevant. If I knew it was descending, again, I would know that triangle would be greater than square, making, again, this card irrelevant. So I believe that I think we can deduce that the solution should have no order. So let me go ahead and type that up in our notes here. And, you know, I've seen other puzzles kind of follow the same sort of pattern. So, you know, once you play enough of these puzzles, certain things start kind of popping up and you notice it more easily. So again, the solution has no order. Okay, so let's see, what else can we do? So basically then it comes down to A and C, and notice that in our 6 criteria cards there is no mention of circle. So somehow that circle digit is going to be forced into a particular odd value. So it could be because of the no order, sort of again shifting to, you know, one digit or another. So And I really don't think there's any way sort of to deduce what these values may be. It could be that, triangle is equal to 3, and then that might be greater. But of course, well, okay, and so let's go back to say criteria card D. Now we can say definitively that it can't be a triple digit, since we do have an odd, even, odd. So we are looking at an all distinct solution of odd, even, odds. And again, anything's possible. So let's go ahead. We'll say, because they're going to be distinct, let's go with 3, 4, 1 and see where that takes us. Okay, so let's go ahead and test criteria card A. Okay, lucky break. So we were able to get triangle pinned down in one test. So it is true that triangle is equal to 3. So let's go ahead and type that up. And of course, that really helps us out, because now we can cross out, the 1 and the 5. Just experiencing a little bit of lag time here. Okay, so there's our 3. Now let's see, let's test criteria card C now. Okay, so in this case I was incorrect. Notice that in my proposal I have 3 for triangle, 4 for square, so I'm displaying a triangle that's less than square, but that is incorrect. And we also know they can't be equal, since we're dealing with odds and evens, so we can deduce that triangle should be greater than square. So let's go ahead and type that up. So triangle should in fact be greater than square. Yeah, I'm just experiencing a little bit of lag, not sure why. So what does that mean if triangle is greater than square? So that would mean that square cannot be a 4. It would force square to be a 2. So let's go ahead and cross out the 4 for square. And so now, let's see. Well, this is interesting. Perhaps my deduction is incorrect, because if there were to be no order, well, let's see, hold on. I see, okay. So because the digits, there are no pairs, they're all distinct, let me go ahead and cross out the 3 for circle, because they are distinct. I can't have 2 3s. So yeah, so again, based on criteria card C and F, how we discussed it, it should have no order. So I'm going to say that the solution should be 3, 2, 5. So let's go ahead and type that up. Okay. And again, we are deducing that it has no order based again on criteria card C and F. Well, let's go verify. So 3, 2, 5. Fantastic. Okay, So let's see how we did versus the Turing machine. So this time we're fortunate that we only needed to test 5 criteria cards. We deduced F, so that is really a almost a guarantee that we beat the Turing machine. So notice that we did do B, D, E in the first round, and we got B incorrect. And then we only tested A and C in the second round, and C was incorrect. So let's go ahead and type that up. So B was incorrect, and then we did D and E, and they were both correct. In the second round, we tested A and C. A was correct, C was incorrect, and we did not test F. Okay, so we still just beat it by 1, but hey, that's still a great result versus a Turing machine. I think it kind of went pretty straightforward in some sense. What do you think? How did you solve? Did you see any inconsistencies or inefficiencies in the way I solved? Please do share your ideas in the comment section. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, hit subscribe to be notified of the next video so you don't miss it. Well, until next time, have a great one.